Why, hello there. Thanks for joining. It's been a while since I've been on YouTube, and I apologize, but I'm going to try to get back into it if I have time. But with that said, today I'm going to showcase the working Freespin model roller coaster that I've been selling. I've done 2 runs, and this is the last batch that's going out the door. I have 10 left. Link in the description. Make sure you get your own, because after that, I'm going to take a break from these and move on to something bigger, better, awesomer. Who knows? We'll see kind of what comes out of that. But at least for today, I'm just going to talk about this model. Actually, let me get a better image of it. This model, and kind of showcase a little bit of the CAD design and what goes on. So if you stick around, I'm going to show you how I designed this and all of the behind the scenes that you might want to see. So first off, let's just talk about the model as a whole. Each model comes with one of these light controllers that if you point at the infrared sensor, it can turn it off, it can turn it on. You can change to red, green, blue. You can turn it to purple, which would match. I don't know if it shows up that good on the video. You can strobe through all of the lights. You can flash through. Smooth? I don't know what smooth does. I guess it just smoothly goes through. So yeah, it's got all these little features. You can change all the colors to something cool. I'll just do white for now so you can actually see what's going on. So that's cool. The lights are totally independent of the lift hill, which is using this switch down here. So you can activate the switch and you can see the train go up and around. Woo! Pretty sweet. The other cool feature with this model is that each one is controlled or powered by a USB cord. So you can plug it into your computer if you have it on your desk. You can get one of those USB adapters. You can literally use your iPhone charger if it's the old one with a fat USB. So yeah, that's the overview. I could literally hit this thing and let it run all day. It's literally awesome. The base is CNC routed wood. The light strip diffuser is a laser cut acrylic, and the structure and ride vehicle are 3D printed. The lift hill is actually just Lego chain. It's nothing crazy, just Lego chain. So that's the overview. We could show some more footage of it running in a little bit, but let's dive into the actual CAD model. All right, so here we are. We are in SolidWorks. That is the design software that I use to design the model. I don't even know where to start. This is the full assembly. There's a lot to talk about. So if I miss anything in the comments, let me know, and I can always do like another follow-up video of like, hey, how'd you do a specific thing? How'd you model it? Blah, blah, blah. Any questions, put it in the comments. Let me know if I miss anything. So the first thing, it's literally at the top here. I have this skeleton sketch, and this is the starting point. I always start with like a rough skeleton of like the sizing. And to get this profile, I literally went to like the S&S website where they had an image of a profile of one of the Freespins, and I just overlaid it. And you'll notice instantly at the top, to make it like match perfectly to scale how they do it, the actual top of this was short at the beginning because I tried to make it as authentic as possible. And what happened is I actually went through all of this prototyping and ran it, and it would not clear this second hill, like the loop back. It would actually stall out, and I was like, oh my gosh. So I literally went back and actually had to adjust the height of the lift hill just because the efficiency of the train was so bad. You would never have known this because obviously I just kind of made it, the finished product work, but literally I went through and designed the whole thing and then had to go back at the end and adjust the height of the first lift hill just because it wasn't making it. So that's a cute little tidbit that was just driving me insane. All right, so now that you know kind of like the framing of it, the very first thing I did was make like one solid track piece because this is going to be mirrored, right? So all I did was take that sketch, so you can see it right here, right? This is the original path, which I just, like I said, just kind of followed it. And then I swept the profile, which is literally an L, just for this model. Swept it around and then put all of the bosses for the supports. And there's no real rocket science to this other than there's a bunch of vertical ones and then the angle ones. All I had to do is make sure the centers lined up and then staggered them appropriately so that the upstop wheels wouldn't hit. And as you can see, I kind of worked quickly in the assembly format. So like a lot of people that would look at this be like, this sketch is very undefined. And I would say, well, I'm the one modeling it. I'm the one using it, so I don't care. So yeah, bad modeling practice, but whatever. This is literally the starting point, and you'll see it's not even split up. What then I do is then take this section and mirror it the appropriate width for the car, and then we already have our running rails. So that's exactly how the track is developed. And then I can go in and then split it up, and what I did is labeled it. As you can see, 1B, 2A, I think 1A starts down here somewhere. So yeah, they're all labeled, so I know exactly where they go. The cross ties, pretty simple. They're actually press fit in, and I made a little note. This was literally developed using trial and error of like the tolerance fit. It's actually using the printers that I use. It's almost nominal. So if you make it a nominal touch, it will just perfectly snap in. I have two styles of cross ties. The one actually just patterned around here is actually the cross tie for the lift hill. And for the lift hill, it actually, the lift hill chain guide is snapped into these cross ties, as you can see here. So the chain guide is pretty straightforward also. It's designed as one piece, and then I always design the whole and then split it up for 3D printing. At the top, it just kind of goes to one of the cross members, and then all the other features, they just snap in to the cross tie itself. And this is the chain guide. The chain guide is developed by the width of the chain itself, or the chain link. And in this case, we used a Lego chain, because why reinvent the wheel when this works perfectly? The size is awesome. I love it. What I did is even have, so this is the one chain link that I use for guiding to make sure everything fits in. I even made a small assembly, which is right here. I can show that. So there's a bunch of them linked up just to make sure that it's all good to go. As far as like how many chain links, that was literally just kind of feeding it through up to the top sprocket down here, or up there, and then down here to the lower one, and then just kind of counting them out, making sure the one's right length. And then there's two ways you can do it. You can literally like lay it out and then make a bunch of links and make sure it's the right length, or you can do it by weight. A lot of people do it by weight, since you know exactly the weight of these things. So that's basically how the chain was designed. Literally took a Lego chain, spec'd it out, and then made a trough for it, and then made sure my train could engage with it. The actual chain dog is a little plastic piece that sticks out, and if you ever are wondering, it's like, hey, it's a small little piece. If it breaks off, I literally have thousands of them. I'll ship it to you for free if it breaks off. I haven't heard or seen any of them breaking off, so there has been no issue. But as far as like the clearance here, I'll give you a top-down view. This is the stack up of how it all goes, and the dog the dog engaging the chain, and the spacing between everything. I'm sure you'll notice in this image there is no side friction wheels at all. Exactly. There's only road wheels and upstop wheels. There's actually no side wheels, and you'd be like, why not? The original reason was I could not fit them in correctly. I was like, this is not working. I even like threw them in on the side, and it just did not work at all. And I got just the funny idea. I'm like, do I even need them? Like, this thing's just gonna probably be bouncing in the rails. Do I really need them? So I just made a really smooth surface on the train. And actually, let's just open up the train so I can show you. A really smooth surface, and it rolls perfectly, because the trick here is how you 3D print it, what orientation it is in. The train's split into two pieces, so I don't even need supports. So it's actually printed on the bed like this, which means my layers, if I do like a section view here in the correct orientation, which it's just going to be difficult. So if my layers are set like this, that means when the train's kind of running, it's kind of hitting a smooth surface. It's not like hitting the layers on there. So it's excellent for just gliding through. So you know what? I was like, let's leave it and roll with it. and it works great. So this is the bottom half of the train, and we will go, I'm not going to save anything. Nope. And this is the top half. So I could 3D print the train without even using supports. And then there's 2 fasteners that go through at the top that kind of put it all together. And actually, the one thing here is to make sure that these fasteners don't come out. I actually cut part of the surface. Actually, I think it's in here somewhere where I can show you. Don't know where it is. It's somewhere in there. Maybe I did it post, but I actually took off just a little bit to make sure that there was an interference there. For the seats, I guess we'll try it this way. For the seats, they rotate, and there's no real trick here. It's just 2 pieces that are inserted into each other. So let's hide that one, and we'll hide this one so you see exactly what's happening. There's just a little rod that goes in there. It's a friction fit. It just presses in. So if you get a model, you could probably literally pull it apart. Would not recommend doing that, but you can actually do that, and that is how those are designed. The seats aren't really crazy detailed because they're so small. Like they're teeny tiny. There's no reason to get that level of detail in there. And then yeah, the chain dog here, you can see it just kind of floats in there, or press fits in there. So yeah, that's the train. That's how it's all assembled. And then there's 2 bolts that go through, and they just feed in. This hold is undersized for the threads, so I don't need bolts. That's also why you'd say here, don't need nuts. Same thing here. It's all undersized so that the threads are self-threading, self-tapping. Let's see what else we can show you. Okay, so that's kind of the train. Talked about the cross ties. The supports, nothing really innovative here other than we have two joints. So we have a T joint and then a 90. The T joint is designed like this. The idea is if we have a rib feature here, when you go to 3D print the rib, let's go back this way. Let's just do it this way. Pop, pop. And we'll turn it around. As you 3D print, you'll never need supports because this rib is constantly building under where that feature is. And so that was the main thing about designing this. It's always designed for how you're going to manufacture your parts, and that's why the ribs here. So instead of like taking it off or like printing it like this, you'd have to have supports. The cleanup would be terrible, and then the part would actually kind of look kind of bad sometimes. So and you don't even notice this feature really. It kind of just looks like a gusset rib on there. So that's why. And same with the 90 at the top. It's literally it's got a rib on the side there. So the same thing was done at the top. No supports needed. Prints instantly. No post-processing cleanup. These are just little tricks that you can think about in order to speed up your post-production of whatever models you're working on. Let's go down to the base, how this is designed. So there's 2, like I guess, sides of it. We have the switch side, and then we have the motor side. The motor side literally has a top bracket that hides the motor. As you can see here, it just slips on press fits and then is like rock solid to hold it all together. The sprocket is literally just a Lego chain sprocket that's designed to fit right onto the motor. And then inside this little tower here, this is the circuitry that relays, actually let's see if I can go, yeah, relays the information to the light strip that then powers the lights and controls all that fun jazz. And there's also wiring that comes down from here to the switch in a channel under here. I'm going to show you in a second after we hide that. That will then turn the lift hill on. If I go under here, there's literally I don't know what you would want to call this, like a housing for all of the wiring. And if I hide this, the way this is made is the entire base of the model is on a sheet of plywood, and we route out the whole perimeter. And then I take the base plate and then router out a slot. So this housing is literally the size of the router bit, which I believe is 3/4 inch. And then I could set the depth of the router and then I go to the hole where the switch is, and that's how I channel out where all of the lights go. And then you'd say, well, how does it get to the light? Well, it's not shown in the CAD model, but this channel on the top where the light strip is, I actually plunge down deep enough so that these two intersect. I just don't show it in CAD because there wasn't a reason to make sure that, you know, it's totally perfect, because I already knew the depth that I would need to go to. So yeah, that's pretty much the model in the CAD design, and it was a lot of fun to make. Like I said, I've actually gone through three revisions of this to make it work. Lots of trial and error. The one key thing that I actually thought was great is when I designed the chain here, there's these two features, like I like to call them a chain guide, that really wraps the chain around the main sprocket. And when designing this, it looks silly, but like I said, I hate using the supports for the model. And when you lay it on the print bed, you don't even need any supports on here. It just kind of comes out like this. So that is the trick, and it's split between both of them. So if I go to the other side here, you can see that, you know, we put it on the plate this way, and then it would build up from here. So no supports needed. Always designed for the manufacturing that you're going to be using. I love it. Okay, so there's one last thing on the model that is innovative, and I thought was a really good solution to a problem that I had. So when putting this together, the cross ties actually keep the spacing, but I needed to assemble it in a way that, you know, it kept everything kind of spaced already. So the cross support between the supports actually has a boss feature that when you press the rails in to then clip it together, it actually spaces it with this extra round. I just revolve the feature around it. So this kept all of the spacing. And then also, like when it is assembled, the cross tie keeps the spacing, but also you have this extra feature to really hold in the tracks at the right gauge. So it was amazing because it really helped with the assembly. And then when you 3D print it, also did not need supports on this, because adding a little chamfer, or actually I'll show you the sketch of this. If I did the right one, there we go. I created a little chamfer so that as it printed, you wouldn't need supports, and then this would help keep the gauge as you assemble the ride. So that was another cool little development that I thought, you know, was pretty helpful. So yeah, a lot of cool things. I feel like in every video, maybe I could give you a SolidWorks tip. So SolidWorks tip of the day, and I'm sure you saw me doing this and you're like, hey, how you did that fast? In SolidWorks, if you hover over a part and hit tab, it will instantly hide that part. It will hide that part. Isn't that amazing? And then you just hit Control Z and it'll pop right back in. It's a lifesaver. You know what you could do if you don't like this trick of the day? You can literally right click. Oh my gosh. Right click and then go to hide component. Right click, hide component. Right click, hide component. Yeah, it takes forever. So there you go. Tab. Tab is the coolest hiding feature ever. And I hope that you learned something. I hope you learned something today. That's brutal. Ooh. So that was the CAD model. This is the real model. Go to the link in the description if you want your own. Like I said, this is the last batch I'm doing for the near future, or if it definitely, I don't know. I'm just done for the moment. We're gonna do better things, cooler things, awesomer things, other models. This thing is literally so much fun, and I just wanted to share the design process, what I've learned, what I did, and really just the behind the scenes. So with that, I'll let you go. Have a good one.